Okay, so before we get into, we're not doing any new material today. We're going to pedal on the old material. I want to see if we can competently execute the application of these criteria of adequacy that we were talking about at our last meeting to judge whether which of two competing explanations is the rationally superior one. But before we do that, I want to draw our attention to something because there was a homework assignment not too long ago on enumerative generalization. There was a free response question at the end. Do we all remember it? Yeah? Okay. And that free response question just said, make a generalization of the form most blanks are blank. Show me some justification for that generalization and explain why your justification is good. I got a wide variety of responses, and I was a little bit concerned mostly because not many of them actually gave a justified generalization. There are all kinds of different sorts of responses. So if you look on one side of this worksheet that I just passed out, not the side that says dark sucker theory of light bulbs, but the side that starts with, it has a whole bunch of different sections. The first one is circular argument, then appeal to authority, then explanations, and last but not least, enumerative generalization. These were the patterns of argument that I saw. I'm leaving out all the folks who just made the generalization. They just said most blanks are blank, and then that was all they put. Like, obviously, you didn't get full credit because you didn't answer the entire question. That makes sense, right? Because it asked you to not just make the generalization, but support it and explain to me why the support is cogent. What I got from lots of other folks, most other folks, was one of these first three different types of arguments. So let's look at the first one. The first one was circular arguments, and I got a lot of circular arguments. Let's see if we can identify why it is that this is not a generalization, perhaps, and also that it's a circular argument. The first one that we have here, and these are chosen at random with a little bit of changing here and there just to kind of anonymize things. Let's start with this one. Teen mothers do not stay with the father of the child. Nearly 80% of teen fathers do not stay with the mother of the child. This is the conclusion, right? That most teen fathers don't stay with... Yeah, wait, is it mothers don't stay with the father? Or is it fathers don't stay with the mother? That's not really clear. And I'm not sure which of those two is actually the conclusion. But is it clear enough that like one isn't necessarily evidence for the other? They're two distinct statements? All right. So let's assume that 80% of teen fathers do not stay with the mother of their child. That's the conclusion that we're going for. Fair enough? You guys bored? I see everybody's just kind of like spaced out here. Okay, it's Friday. You've almost made it. Teen pregnancy is closely linked to single parenthood. That's just the same thing, right? We've just said the same thing over again. In fact, a less specific statement. At first we said 80% of teen fathers don't stay with the mother of their child. And we also had this claim teen mothers don't stay with the father of their child. And now we've just said it a different way. Teen pregnancy is closely linked to single parenthood. I haven't offered any evidence or justification for what I've said. I'm just saying it in different ways. These are cogent supporters because they are proven facts. And they support the statement very clearly. Are they? I don't really see how. Do we see how this is a circular argument? I've offered no actual justification. If it seems like I am offering justification, it's because I'm just stating the conclusion again in different words and expecting that like that's going to support my conclusion. But your conclusion can't support your conclusion. If you're using your conclusion to support your conclusion, it's circular. Good. Let's look at the next one. Most cows are not going to live out their full lifespan. Cows are often slaughtered for meat by 18 months, and their normal life expectancy is 15 to 20 years. 6.6 million cows are slaughtered around the world each year. 6.6 million cows are slaughtered around the world each year. Is that part of the argument at all? That seems like it's just a little bit, maybe it's window dressing, maybe it's a red herring. It's not offering support to this idea that most cows don't live out their full lifespan. What about cows are often slaughtered for meat by 18 months? That's just most cows don't live out their full lifespan. I've said it again in slightly different words. That doesn't offer support because it is the claim that needs support, and this is why it's circular. Do we get why these are not, first of all, they're not good arguments. And second of all, they're definitely not justifications for a generalization. Cool, cool? All right. The other sorts of arguments that I got were appeals. Oh, yes? We need another one? Here you go. You can pass that over. The other sorts of arguments that I got were appeals to authority. And these are a little bit better than circular arguments, but they're really not quite generalizations either. So for example, most cows are pretty smart, as proved by animal scientist Steve Davis in 2005, who found that cows experience a wide range of emotions and can be moody at times. They feel pain, anxiety, fear, and are intensely sexual. Ooh. Okay. If that is justification for this idea that most cows are pretty smart, that justification is because Steve Davis says so. And that can be a good argument, especially if Steve Davis is a legit authority who deserves our trust. But it is not a justification for a generalization. Does this make sense? This is a little bit different than the circular argument because I'm not restating my conclusion. I'm saying an authority is giving you my conclusion. We haven't really discussed in great detail how it is that these arguments work. We will be talking about this, I believe, next week. But this is not a generalization. It's a different kind of argument. We got the same sort of thing going on here. Most college students are liberal, according to studies that show 64% are. 64% of college students are liberal, and most college students are liberal are pretty much the same sort of statement, right? One's just a little more specific than the other. And the only thing that I add by saying studies show is some sort of authority. If I had explained how those studies worked, if I had explained their sampling method and how it is that we made a generalization from some evidence in those studies, I would have explained how my generalization works. But as it stands, I'm not making a generalization here either. I'm just leaning on the authority of studies show. Is it clear how that's not the same as an enumerative generalization where I say case, 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 pattern, therefore most A's are B's, right? Questions so far about this? This was a little bit, can you see my concern? Because it was an assignment, we had just spent we had spent an hour talking about how to do generalizations. It was at the end of a homework assignment that was all about, here's how generalizations work. And then I said, make a generalization, and lots of people were doing things that were not generalizations. Let's look at one more type, and this is maybe relevant to the sort of thing that we're talking about today. A lot of folks offered explanations as justifications for the claim that they were making. And this doesn't really quite work as a good argument the way that it's being done here, and it's not a generalization. So most subscribers to Vogue magazine are women. This is supported by the common misconception that fashion is indeed for women, an age-old conception that originated from the fall of feminism after World War II when the men returned home. It was then believed that women should be associated with the home as fashion enthusiasts and homemakers. Society's burden on women to uphold this image is carried out through all of society, pressuring women to look nice and care about fashion. Hence, most of Vogue magazine sales are from women. There are some obvious places that I could go to try to justify the claim that most of Vogue magazine sales are through women. But I haven't really done that. What I've done is I've made the claim, and then I've explained why it is that that claim wouldn't be surprising. But I haven't given you evidence that the claim is true. If that claim was true, and I was wondering, why is that? That's surprising. We need an explanation. Then we'd be doing the sort of thing that we're talking about today. These explanations, these abductive inferences, they work when the thing that needs explaining is already accepted as true, is functioning as a premise. And I'm wondering, why is that? And if I can give you some sort of explanation that explains why that would be true, and it's superior, it's rationally preferable to all of the other competing explanations, then I can believe that those explanations are true. I have reason to believe that those explanations are true. The explanation is the conclusion. The thing that needs to be explained is a premise that supports that conclusion. Does that make sense? Okay, so what we have going on here is the thing that needs to be explained is being put forth as the conclusion, and the explanation is being offered as support, and that doesn't quite work. I haven't been given reason to believe, or as I certainly haven't been given reason through some sort of function of enumerative generalization to believe that most Vogue magazine subscribers are women. I'm given an explanation for why that wouldn't be surprising if it were true. Do we see the difference? Let's look at one more. Most ketchup is red. Ketchup is made from processed tomatoes. Tomatoes are red and produce red juice. Therefore, most ketchup is red. Again, most ketchup is red is the conclusion. If it were a premise, if it was something that we all agreed, most ketchup is red, and then I was like, why is that? And we were looking for an explanation, and we offered this explanation and say, like, oh, that would make it unsurprising that most ketchup is red. That would function, and the explanation would be believable because it explains this fact, or this explanandum, this phenomenon that demands explanation. What I've got here is a conclusion, and then I'm being offered an explanation to support that conclusion, and that's not really quite how generalization works. It's not even really quite how justificatory support works. This generalization is cogent because my conclusion is a result of the highly likely premises I offer as a follow-up. Okay. Here's one that does do a generalization, and there's a little bit of room for critique, but it's got the right form at least. Most undergrads are between age 18 and 22. Anytime I ask an undergraduate how old they are, they tell me an age between 18 and 22. Also, usually start school around 5 or 6 and graduate around 18. This argument is cogent because blah, 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 blah. Do we see how this one is following that form of an enumerative generalization? I have a sample. The sample exhibits a pattern. I'm trying to suggest that the sample is representative of the entire target population. Therefore, the entire target population matches the sample. How would you... Do we have any concerns about that argument? Any things that were kind of like, I'm not really, there are places where I could critique it, yes?
How many people they ask?
Yeah, we're a little vague about the sample size, right? Whenever I ask an undergrad how old they are, they say between 18 and 22. How many times? 2 times? Did I go into the bathroom and look in the mirror and I say, hey, how old are you? Oh, every time. Did I ask a bunch of my friends? Even if the sample size was large, do I have things that I'm concerned about here? Yes?
The second support assumes that people go directly from high school to college.
It does assume that people go directly from high school to college. It might suggest why we might not see anybody much younger than 18, although we know this can happen if people skip grades, but we'll also say there are only so many grades that we'll expect somebody could skip. But yeah, we might say that would suggest that it was unusual, but then we'd be drifting into explanation territory as well, right? We'd be saying, if it were true, and we were wondering, like, why is that? Why is it that most college students are between 18 and 22? How come we don't see any younger? We say, like, well, because to get to college, you have to go through all of these other grades. It takes a certain amount of time, and you're not allowed to start that process until you're 5 or 6. That would be an explanation, but not justification for the generalization that's being made. What is justification is the survey that's made, right? It's kind of like I asked a bunch of people, how old are you? You college student? Oh. And they were all between 18 and 22, and they were all college students. Therefore, most college students are between 18 and 22. Concerns about not the sample size here, but the representativeness of the sample? Yep.
Maybe like certain formats will have different age groups. For instance, Brian's school has a lot of might have a lot of undergrads who are kind of older because a lot of them are accountants, finance people, and they left a job, and now the new market says you have to have a degree. So now they're here.
Is there maybe good reason to suppose that, like, the person who's making this argument and did the survey, they might say, well, then how come I didn't run into any of these older students in the business school? Like, we would expect if they were out there that I would have run into them and asked them. Do older students tend to run in the same circles as younger students? No. No, okay. They might not hang out on campus for very long either. They might finish up their classes and get right out. So there's maybe good reason to be suspicious of, like, yeah, I asked a bunch of people, and I'm like, where did you find these people? They were all my friends. They were all people who lived on my hall in my dorm. You're pre-selecting for folks that are going to be between 18 and 22 here, aren't you? That's right, yeah. If you did it through classes, and even then we might say, like, wait, which classes? We want, like, a random sampling across the university of classes. We might also say, I don't know, just look through the university roster and, like, randomly select students and send out a survey to them through email or something like that, yeah? And even then, I might be concerned about, like, all right, so who's responding, and is there going to be a bias in who responds? This is, I don't want to pick on this argument too much because it did a much better job than most of the examples. There's still a little bit of room for critique. Do we get the difference between, hopefully we get the difference between a circular argument and a good argument. Do we get the difference between an explanation and a generalization? Because today, we're going to go back to talking about explanations. And do we understand why an appeal to authority isn't really quite the same thing either? Okay. Any questions about this? I'm tempted to put a question like this on the exam just to make sure that, like, folks get it. It's like a little bit, it's one of those things that, like, makes my face scrunch up and makes me kind of disappointed because I'm like, oh, I thought everybody was getting it, and then when I asked you to do it, like, hardly anybody did it. Yes?
With the appeal to authority, could you use that after already given support to your thing as like, also this expert says this?
Also this additional argument, yeah, and then what I'd be doing is I'd say, like, here's my conclusion. It's supported by this generalization. Also, in case you didn't believe the generalization, smart people say so. Yeah, it would be a separate line of support. Yeah.
Would that be ad hoc in terms of the argument?
How do you mean ad hoc?
In other words, if your first assumption or premise didn't satisfy, you used ad hoc to bring in the authority.
Yeah, I mean, we're not really concerned necessarily with, like, the temporal order of, like, when is the support given. Ooh, something's going down over there. There was a fire yesterday. Did anybody, like, in...
A dryer exploded in my dorm.
In your dorm? A dryer exploded in your dorm. Was everybody okay? Okay. Oh, 2 fires in the same day? Art students. So yeah, we're not necessarily concerned about, like, when the support is offered. We're assuming, perhaps charitably, that if they offer the support, I don't care if you did it after we knocked down this first one, but we would be aware that, like, you offered this support for your conclusion, and you're offering this support for your conclusion, but you only offered this support after we showed that that was not very good, and we're just like, okay, so this isn't really there. There's no actual support on that one. This is our argument. I would only have the argument by authority. Or I might say something like, the survey says, and then I'm like, how do I know the survey is good? We might say, because they're trustworthy. And this starts to look a little bit like a generalization, but really, like, what's doing the supporting work? What's doing the supporting work is the appeal to authority. Okay. Light bulbs. How do they work? There's a standard theory that explains this. And we've got both theories here. The first time I started doing this assignment, I got students who would say that the second theory is better than the first theory because it's longer. They didn't say it exactly like that. They said it offers more supporting details. And I was like, what do you mean more supporting details? And they're like, look, there's, like, many paragraphs. And I'm like, longer is not better. Can we all agree there? Can we all also agree that, like, we've got at least an intuition that probably the standard theory is superior to the Dark-Sucker theory? Let's suspend that judgment just for a second. Let's assume that we have no idea. This is the only, or maybe not the only way, but this is, like, something that we might want to safeguard against so that we're not letting our previously held opinions bias the analysis that we're about to offer here. Our standard photon emitting theory works something like this. We say the light bulb has a filament, a thin piece of metal. When I screw the light bulb in and I flick the switch, electricity runs through the filament. That electricity has something kind of like friction. We call this, like, ohmic heating or something like this. As the electrons pass through the metal filament heats up. When it gets hot enough, electrons in the metal get excited up to higher energy states, and then they fall back down. And when they fall back down, they kick off a photon. And the photon is the light. That's what we see. The photons, like, bounce around the room, and then they hit your eyeball, and rods and cones register them, and we say, like, oh, I see light. Pretty good so far, right? Okay. Then we get this Dark-Sucker theory. Shall I read the whole thing out loud? Or can we all read it ourselves? I'll read it out loud? All right. For years, It has been believed that electric bulbs emit light, but recent information has proved otherwise. Electric bulbs don't emit light, they suck dark. Thus we call these bulbs dark suckers. The dark sucker theory and existence of dark suckers proves that dark has mass and is heavier than light. First, the basis of the dark sucker theory is that electric bulbs suck dark. For example, take the dark sucker in the room that you're in. We've got many dark suckers in the room that we're in. There is much less dark right next to them than there is elsewhere. Okay. The larger the dark sucker, the greater its capacity to suck dark. Okay, I see that too. Like big, what light, like standard photon emitting theorists would call light bulbs, big light bulbs or big dark suckers suck more dark. All right. Dark suckers in the parking lot have a much greater capacity to suck dark than the ones in this room. Okay, all right, good so far. As with all things, dark suckers don't last forever. Once they are full of dark, they can no longer suck. This is proven by the dark spot on a full dark sucker. Do we get what they're talking about here? Have you ever had a light bulb, what they call a light bulb, quote unquote, burn out? And when it burns out, there's like a little dark spot inside, and that's the indication. That's because it's full of dark, the dark sucker theory is saying. A candle is a primitive dark sucker. A new candle has a white wick. You can see it after the first use. The wick turns black, representing all of the dark that has been sucked into it. If you put a pencil next to the wick of an operating candle, it will turn black. This is because it got in the way of the dark that was flowing into the candle, and I suppose the dark got stuck to the pencil. One of the disadvantages of these primitive dark suckers is their limited range. There are also portable dark suckers. In these, the bulbs can't handle all of the dark by themselves and must be aided by a dark storage unit. When the dark storage unit is full, it must be either emptied or replaced before the portable dark sucker can operate again. Those storage units, other folks might call them batteries, I suppose. Fair enough. Dark has mass. When dark goes into a dark sucker, friction from the mass generates heat. Thus, it is not wise to touch an operating dark sucker. Candles represent a special problem as the mass must travel into a solid wick instead of through clear glass. This generates a great amount of heat, and therefore it is not wise to touch an operating candle. Also, dark is heavier than light. If you were to swim just below the surface of the lake, you would see a lot of light. If you were to slowly swim deeper and deeper, you would notice it getting darker and darker. When you get really deep, you would be in total darkness. That's because the heavier dark sinks to the bottom of the lake, and the lighter light floats at the top. That's why it's called light. Finally, we must prove that dark is faster than light. I don't know why we must prove that, but okay. If you were to stand in a lit room in front of a closed dark closet and slowly open the closet door, you would see the light slowly enter the closet. But since dark is so fast, you would not be able to see the dark leave the closet. Next time you see an electric light bulb, remember, it's a dark sucker. Let's start here. We have phenomena that demand explanation, right? We have my explanandum. Which is either a phenomenon or a cluster of phenomena that demand explanation. Do we have just one phenomenon or do we have several? I think we have several. What are the things that seem, at least the dark sucker theory seems to be saying, like, we can explain these things? What are they? What's that? That dark is heavy? That's not what, that's their answer. That's the explanation, is dark is heavier. What is it that they explain by saying that dark is heavier? Yes?
Why it's darker at the bottom of the lake.
It's darker at the bottom of, like, yeah, the ocean or a lake or a large body of water. Darker at bottom of lake. What else? Gordon. Hot. Yeah. Light bulbs. And I want to be fair, so I'll go ahead and say, or dark suckers, depending on which theory you're adopting, are hot. And not just light bulbs, but candles as well. Where we have light, we frequently have heat. Yes?
Why light bulbs burn
Light bulbs burn out. Light bulb, aka dark sucker, burn out after a period of extended use. Anything else? Yeah, I don't, like, does anybody else find that phenomenon, like, I'm not sure that, they say this is a phenomenon that we can explain. I'm not actually sure that's true. And all of these things, all the things that are in my explanandum, they need to be true, right? They're premises in my argument, where my conclusion is going to be, this would explain all of that stuff, that, therefore my explanation is believable. My conclusion is believable because of its explanatory power. But these things need to be uncontroversially true first. Is it true that when you slowly open a closet door, the dark slowly leaves? Or aka the light slowly goes in? Like if I open, I'm curious, if I like open the closet door, does the dark closet inside go from dark to light, like it fades up? And if I close the closet door, it like fades back down? Or is it, because my sense is that when I open a closet door, like as soon as I open it, I'll see the boundary between the light and the dark. Let's see if I can actually draw this. As I open the closet door, I'll see the boundary between the light and the dark just move. And it moves just as fast as I move the door, right? So I don't know that like this speed thing is anything just yet. But I'll go ahead and I'll put it on there with an asterisk because I'm not sure if that's actually a thing that needs to be explained because I'm not actually sure if that's true. The whole closet business. Yes?
I would say that technically, like, the photons have to enter the color at the same time, but it's so quick that you can't do this.
That would be how we would explain the same phenomenon through a light emitting theory rather than a dark sucking theory.
Right.
Yeah. So you might say that, but let's not beg the question just yet. Let's not say that that's the answer. So are there any other things that we need to explain? Yeah.
Why you can see in a room with a light or a dark?
Yeah, like basic light bulb operations, right? So light bulbs / dark suckers work the ordinary ways they work. When I flip on a light switch, when I turn on a flashlight, when I light a candle, the room gets brighter, aka less dark. Okay. Anything else? Yep. Candle and also a burnt out light bulb. There's that kind of there's darkness on the wick of the candle. It's black. And if I put something right next to the candle, it turns black too. And when the light bulb is burnt out, aka the dark sucker's full of dark, there's a black spot on the bulb. So some sense of kind of like, there's some blackness or darkness once the dark sucker / light emitter has been running for a while. Okay, anything else? This is like freaking me out. The light bulb keeps going on and off. It's like, I don't know, am I sucking dark now? Anything else? Yes?
The explanation for why you need storage units for your toilet.
The whole storage unit business. Okay. Anything else? Can we, maybe this is enough to start? I'm running out of board space anyway, but okay. So this is my explanandum. Dark sucker theory says I'm a good theory because I can explain all of these things. This refers to my criterion of consistency. And we have my dark sucker theory, and I have my light emitting theory. And this marker is a piece of crap. There we go. So according to the principle of consistency, what am I looking for? What's going to satisfy my criterion of consistency here? Yeah, are there any of the available facts that contradict the theory, right? And the Darksucker theory is saying we can explain these things, we are consistent with all of these available facts. Are they? Is this true? If the Darksucker theory were the case, then it would be consistent with all of this stuff. Yes? 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 Are we all in agreement? Ding! Can the light emitting theory also explain all of this stuff? Is it consistent with all of these things as well? If the light emitting theory was true, then we would be able to explain why it is that when I flip on the switch, the room gets brighter, aka less dark. Would I be able to explain why it's darker at the bottom of a lake? How is the photon emitting theory consistent with it's darker at the bottom of a lake than at the top of a lake? Yeah, maybe the Darksucker theory would say, like, the biggest Darksucker in our immediate neighborhood is up in the sky. You call it the sun, and it is just constantly sucking dark from, like, all reaches of space that it can get to, including here on the Earth. Or we could say it's emitting light. Would that be able to explain why the bottom of a lake is darker? How come the light that's emitted from the sun doesn't get down to the bottom of a lake?
I can't remember the exact reason that has to do with how light refracts through a body of water.
Yeah, it has to do with how light refracts and reflects. It certainly, quite a bit of light gets just bounced off the surface,
Sediments.
right? There's some, the water is not just water. There's all kind of sediment as well. And the light gets absorbed by that. Not just the sediment, but the water molecules as well. Light gets absorbed by all these things, and when the light gets absorbed, it heats up. That's why on a very hot sunny day in the middle of the summer, the lake gets warmer. And on a cold winter day where the sun hasn't been shining as much, the water is colder. All right, so both theories will explain that. They're hot. How does the Darksucker theory say that it's consistent with this? It's because dark has mass. So we have to say this is hot, and the Darksucker theory says this is because of mass of dark. That dark has mass. So that's something that they're assuming. What about the light emitting theory? Is it consistent with the idea that a light bulb gets hot? Yes?
Yeah, the electrical current heats the filament, which generates the
This was part of the explanation, right? It gets hot before it gets light. Okay, good. Moving on. The burnout phenomenon. The Darksucker theory says light bulbs burn out when they're full of dark. How does the light emitting theory handle this? Does it say, like, they're out of light? Or does it do something slightly different? Filament burns out, right? Yeah, so the filament, like all of that heating up and cooling off when you turn the light on and off, the filament, like little bits, I believe the way that we would explain this is that some of the filament actually gets vaporized, and like slowly over time, it gets thinner and thinner and thinner, and when it gets too thin, it just breaks, and now there's no more complete circuit anymore, and the electrons can't flow through it, and then the metal doesn't heat up, and then it doesn't emit light. All right, so we're good. We can explain that one too. The closet thing, whatever, okay. The candle phenomenon. Can the light emitting theory explain why it is that the wick of a candle is black? Can it explain the candle at all? The candle is what, how does the candle emit light, according to the light emitting theory? It's a different sort of a thing than a light bulb. You have to light a candle? You have to start, we might say, like, this is slightly different. It's not an electrical sort of a light emission. It's there's a chemical reaction that gets really, really hot, and then the heat makes all the light, makes the gases that are produced in the combustion so hot that they glow, and this is what a flame is. Why does the wick turn black? It's just carbon soot left over from the combustion process. Is that also why when I put a pencil or something else right next to the candle, it turns black? Actually, now that I think about this, Let's use the red marker for this. They said when you put a pencil up next to the dark sucker, it turns black. I don't know why a pencil, but okay. When you put a pencil up next to the dark sucker, it turns black because it's getting in the way of all the dark that's rushing into the dark sucker. The light emitting theory would say it's burning. The light emitting theory says it's burning because it's getting too hot. The wood is burning just like the wax and the wick are burning. What side of the pencil will we expect to get dark according to the light emitting theory? The side that's closest to the flame? The dark sucker theory says the pencil's getting in the way of all the dark that's rushing in. What side of the pencil will we expect to get dark according to that theory? The opposite side. Ooh, this is... We've got a test. These two theories would say very different things about what happens here. How does it turn out? I don't know off the top of my head. Duh. I'll pretend like I'm stupid. I have no idea. But if we wanted to do an experiment, we could figure it out. Okay. So they can both explain it, but they're gonna give slightly different predictions. Okay, good. That's good to know. And the storage unit business? The dark sucker theory says a portable dark sucker needs an additional storage unit. When you've run it for too long, it gets full of dark and you have to empty them out or get brand new empty dark sucker storage units. Light emitting theory says everybody's whispering. It's because you're not confident about like how a flashlight works? You've replaced the battery. Why does the battery work according to the light emitting theory? Because it generates electricity, again, through a chemical reaction, and it can be used up, right? There's a whole, take an intro chemistry class, there's a whole business about like redox reactions. Okay. So both can explain all of these phenomena. We have like this interesting test about the pencil and the flame thing, that they're going to say slightly different things, but it looks like both of them are equally consistent with the explanandum, with all of the available facts. Okay. What other criteria do I have? Simplicity is one of them. Conservatism is one of them. Three down, three to go. Scope. Fruitfulness, testability, and that's it, right? Testability, fruitfulness. Okay. Start at the top and work our way down. Josh, question or?
Yes. But I think I found the point where it like contradicts itself.
Where it contradicts itself. Oh, so we're saying consistency is a big deal.
But it might be an implication.
Okay, yeah, let's hear. What is it? Does it seem self-contradictory?
I thought about it when you were talking about how like the candle and so it was like if the candle is sucking in the dark and by sucking away the dark there's light and the dark has mass and is being pulled into it, why is there light in the first place if it's just being sucked in? Like
Where does all the light come from? Is that what you're wondering? For that matter, where does all the dark come from? For that matter, where did the universe come from? These are big questions. And maybe we're not responsible to answer them just yet, right? And we might say that, like, when God created the earth, or when there was a big bang, or like, pick your theory to explain why there's something rather than nothing, a certain amount of light and dark were thrown into the universe. Maybe. So yeah, I'm not sure if this is a consistency issue. It might be this question of like opening up into, this might come down to questions about fruitfulness or testability or something like this, where we might say like this opens up into new questions. Can we answer those questions? Perhaps, okay. Yeah, keep that one in mind. We might be able to settle this without having to get to like where does all the light and darkness come from? Simplicity. Is one of these theories simpler than the other? Yes? Which one and why?
The first one is because the second one gives so many explanations and so many different ways to explain it. I feel like it has it's more simple.
More simple?
The first one.
Interesting. It's almost like you've done the opposite of the people who say, the second one's longer, therefore better. You're saying the second one's longer, therefore worse. Because it's more complicated? Maybe they're just going into more detail. Maybe they're just fleshing out. Possible. Does it seem like it's more... Does it make more assumptions? It does make more assumptions. What are the extra assumptions that the Dark-Sucker theory makes that the light-emitting theory doesn't have to make? Dark has mass. We have to say that dark has mass in order for the Dark-Sucker theory to work? That dark is fast. Faster than light, but that was the closet thing. In fact, I think that just confuses things unnecessarily.
Not only is dark,
Dark is heavy, which is it has mass, right? The dark has mass and it's heavy, and it's heavier than light. We have to use this in order to explain it. I think they may be unnecessarily hamstring themselves. I can think of a Dark-Sucker theory where we say that dark doesn't necessarily have mass. If we're talking about like why is the bottom of the lake so dark then, we could just say because the Dark-Sucker can't get all the way to like the same way that like for the same reason that my vacuum cleaner doesn't suck as well on the opposite side of the room as it does like the stuff right next to the vacuum cleaner, right? So I could just say that, well, it's because there's water in the way. No, all right, yeah, dark has mass, that's an extra assumption. Any other assumptions? Yes, Charles.
It seems like it's assuming that there is both light and dark.
We have extra entities.
Different things, and in all areas where a dark sucker can be used to its practical effect, but when letting us see, there must also be light there. So light must permeate all areas where a dark sucker.
That seems to be interesting, yeah. So the Dark-Sucker theory is saying that there's a thing called dark and another thing called light. What about the light-emitting theory? Does it also say there's a thing called light and a thing called dark? There's light, and then there's like absence of light. But that's not a separate thing. It's just you're missing the first thing. Dark isn't its own thing. Do we think we can make the Dark-Sucker theory work where like we would say, all right, fine, we don't have dark and light. We just have dark, and light is just the absence of dark. We would have to amend it a little bit. And if we did, we wouldn't have to make that assumption. I'm going to go ahead and say, all right, simplicity goes to the light-emitting theory and not so good for the Dark-Sucker theory. But I'm going to asterisk that too, because I think we might be able to rehab the Dark-Sucker theory a little bit to be simpler and still be distinct from the light-emitting theory. Cool. Conservatism. Is there an edge? You guys packing up. We got minutes left still. Yeah.
The light emitting theory is more conservative.
Light emitting theory is more conservative? We called it the standard theory.
and it accords with everything else I think we know about.
So this one would ask us to like change our mind about the way that we understand the universe. And in order to do that, we would have to say like all other things being equal, like that's not going to be very good. You would have to have a serious edge someplace else. So again, okay, not so good here. That one's easy. Scope. Does the light emitting theory do more work than the Dark-Sucker theory? Does the Dark-Sucker theory do more work than the light emitting theory? Ooh. Is it really?
And it makes grander assumptions.
It leaves more untouched.
What do you mean leaves more untouched?
Leaves less questions by giving more examples.
It offers more examples, but it seems like the light emitting theory can handle those examples as well, right?
It could, but I know we were even saying like some stuff the dark theory didn't have to say, but by saying it, it kept you from being able to question, well, what about this?
Ah, I see. So like for what for example? That dark has mass? It didn't necessarily have to say that. But the light emitting theory can... So yeah, what does dark has mass explain? It explains why the bottom of the lake is so dark, but the light emitting theory can handle that. It explains why the light bulb gets hot, because all of like the massive dark is like there's friction as it goes into the dark sucker. But the light emitting theory can explain that as well.
So like the light emitting theory didn't say anything about candles.
That's
Dark
true.
emitting theory did. So it tried to touch like all.
Could it? Could it? Could the light emitting theory, if we were to say, like, I didn't know you were going to talk about candles, but we could talk about candles too. In fact, we could also talk about, ooh, have you ever noticed how if you stick something metal in a fire for a long time, it gets glowy and emits light or sucks dark? Can the darksucker theory explain how it is that a piece of metal in a fire turns into a darksucker?
But it never even explains the exact,
Doesn't explain the mechanism at all.
it just sucks.
Yeah, it's like, yeah, it sucks. Like, ask the engineers. They'll tell you how it sucks. Yeah.
Light emitting theory's scope is greater because it makes one scientific assumption that then applies to every other scenario, whereas the darksucker theory has to go through and individually try and come up with a reason for each one. It doesn't have one grand explanation.
Okay, yeah.
I don't know. The way this is all worded and presented, I would argue that the photon emitting theory does make a lot of assumptions. That's probably more than the dark
More than the darksucker theory, which would make it less simple. In fact, we'd have to go back to simplicity. I'll go ahead and leave this one open for question. Testability?
How can we test the mass of that?
How can we test the mass of a darksucker? I can think of a couple ways. They say that when a light bulb burns out, it's full of dark. Can you test whether or not that's true? Especially, yeah, weigh it. Weigh a light bulb brand new, weigh a light bulb after it's burned out. They'd both be testable. They would have to pass that test, though, right? And what would you expect to find? Also, if dark has mass and a light bulb is a darksucker, I could just take like a two-beam balance, take a flashlight out, shine the flashlight on one pan. What would you expect to see? It's sucking all the heavy dark up off the pan, so that side should go up and the other side should go down. This is a test that we could run. And if it passes that test, bully. The light emitting theory says photons are shooting out of the flashlight, and so when I shine on, we'd expect it to go the other way. Which way does happen? Does either? If you shine a flashlight on a balance, does it change?
It gets heavier. Photon.
It gets heavier, but like you'd have to have a really sensitive scale in order to notice it. And we also had that flame test too thing. So they're both testable, but I suspect that and this is going to run us back to consistency again. I suspect the light emitting theory is going to pass those tests better than the darksucker theory would. Not enough time to talk about fruitfulness. Do we get how this works? Do you get, like, if I gave you two competing explanations, or if I gave you a phenomenon and said, explain it, and you found two competing explanations, you'd be able to say, like, these are the things that need to be explained, and I'm going to run it through these criteria? Good, because this is your next argument analysis assignment. I'm going to give you a phenomenon that needs to be explained, and I'm going to ask you to tell me all of the things that need explaining. Tell me the two competing explanations that you can find, and run it through my criteria of adequacy.